Good afternoon, children. Welcome to SBR PUC online classes. As in the last class, we have started new topic, hydrocarbons from organic chemistry. You may be remembering that, children. Yesterday, we have completed introduction and just we have started with method of preparation. Let us move to the same topic, hydrocarbons. As we said in the previous class, children, the compounds of carbon and hydrogen and their derivatives, we can call it as what? We can call them as hydrocarbons. And when we are dealing with hydrocarbon, always you need to remember that hydrogen atom can be replaced by other functional group or the substituents. Let us continue the topic, hydrocarbons. As we have started in the previous class, subtopic in hydrocarbon, that is alkenes. Let us continue from methods of preparation. As one method of preparation, we have completed in the previous class from alkenes and alkynes. One method we have completed from alkenes and alkynes. Let me repeat before going to the second method. Carbon-carbon double bond or carbon-carbon triple bond by addition reaction. That too, addition is catalytic reduction by passing hydrogen gas in presence of nickel, platinum, palladium as a catalyst to convert it into carbon-carbon single bond. But when you are taking a carbon-carbon triple bond, 2 moles of the hydrogen has to be added over here. Why it is so means because triple can be converted into double bond, double can be converted into single bond to get the molecule as containing carbon-carbon single bond or saturated hydrocarbons. As we have simple example, one related with ethene on hydrogenation. Ethene on what? Hydrogenation in presence of, they are going to heat more than 500 Kelvin. So here we are going to get what? Carbon-carbon single bond. It will be in presence of catalyst. As I said that catalytic reduction. Presence of catalyst are called as catalytic reduction. Okay, and here carbon-carbon triple are there. Like ethane on reduction. By taking the 2 moles of hydrogen are converted into ethane. Again, the same condition will be maintained. They are going to heat at high temperature and they are going to be maintained in presence of catalyst. In presence of what, children? Catalyst. We are going to maintain the temperature more than 500 Kelvin. We'll maintain around 525 Kelvin, something around, or 575 Kelvin. Temperature not a condition that we should write the exact value over there, but it should be approximately, we can write more than 500 Kelvin. More than 500 Kelvin because all these are catalytic reduction. One more point, as I said in previous class, that this catalytic reduction is what, children? It is a adsorption reaction. It is a adsorption phenomena. That's why they have mentioned over there one point. They have mentioned over there adsorption, AD it is, superficial phenomena. That's why they have mentioned one word in this one explanation, that hydrogen is going to be adsorbed on the surface of nickel, platinum or palladium. Nickel, platinum or the palladium, hydrogen is going to be adsorbed. As it is going to be adsorbed over there, they are going to form a complex. That complex with substrate molecule, they'll form a complex. That substrate, the substrate molecule complex will be formed, and that can be break up to form product. And the catalyst, because this is a catalyst which can only increase the rate of a reaction, but it doesn't involve in the reaction. It can speed up. It can speed up or it can make easy for reduction. Addition of hydrogen, we can call it as what, children? We can call it as reduction also. We can call it as reduction also. Another point we need to remember that by this method, we cannot prepare methane. By this method, we cannot prepare methane. Cannot prepare methane because methane contain only one carbon atom, will not get any unsaturated hydrocarbon with one carbon atom. To get a unsaturated molecule, minimum we should have two carbon atom. Either they may be bonded by a double bond or they may be bonded by triple bond. The next method of preparation, the second method of preparation is from alkyl halide. Second one, from alkyl halide. From alkyl halide. Alkyl halide is the common name. IUPAC name is haloalkanes. IUPAC name is what, children? Haloalkane. Halo group will be given as a prefix. And here alkyl halide, what? RX, alkyl halide. These are the derivatives of alkane where one hydrogen atom. Alkyl halide are containing only one, but it is possible that all the hydrogen atom can be replaced by halide group. But in this method, we are going to take only one mono or one hydrogen is replaced by halide group. Those are also called as monohaloalkane. They are called as what? Monohaloalkane. Monohaloalkane. We'll move to this method. Monohaloalkane are converted into alkene. RX converted into RH. Correct? RX can be converted into RH. Another point. RX can be converted into R and R. These are the two ways are there by which we can convert alkyl halide to saturated hydrocarbon. These are the two ways are there. Both are going to start from alkyl halide. This alkyl halide by reduction, I'll write here, reduction of alkyl halide. Reduction of alkyl halide or haloalkane. Or haloalkane. RX on reduction in presence of zinc and dilute HCl. Zinc and dilute HCl, they are going to produce RH plus HX. That's why we are going to take H as two nascent. This hydrogen are called as nascent hydrogen atom, which are called as what, children? Nascent hydrogen atom. That's why we'll say that whenever the alkyl halide treated with zinc and dilute HCl, they are going to produce RH. Even one more point you need to remember that zinc and dilute HCl can also be represented as zinc with H plus. Zinc and H plus. Acids can be usually represented as H plus, children, because acids are one which produces H plus ion in aqueous medium. That's why we can write H plus as for the acid. RX are converted into RH. One point you observe over here, how many R are there? Those many number of R I'm getting on the product side. If here R is 1, R is nothing but what? Alkyl group. R is nothing but alkyl group. It is a hydrocarbons alkyl group. Hydrocarbon, it is an alkyl group which on reduction, same reaction, produces 2 X is replaced by H and HX. And HX. If we'll take the example, I'll take the example. Ethyl bromide. One point to remember that alkyl halide which is not used is alkyl fluoride. Alkyl fluoride cannot be undergo reduction or alkyl fluoride is not suitable because first of all to getting the alkyl fluoride only difficult because alkyl fluoride formation is highly exothermic reaction. Exothermic reaction means enormous amount of heat energy will be released. And those reactions are like what explosive type of the reaction. That's why such reactions are not preferred. That's why alkyl halide not preferred is alkyl fluoride. Come to the point. Ethyl bromide on reduction. On reduction, how many carbon atom are there? 2 carbon atoms are there in alkyl group. That's why the product side will get a saturated hydrocarbon with 2 carbon atom only. Here, zinc and dilute HCl, they are going to produce C2H6, ethane. Ethane plus HBr. Plus what, children? HBr. This is what? Bromoethane. Bromoethane, or the common name we can write it as ethyl bromide. Instead of this one, even we can use CH3, CH2I. We'll take any of this one. On reduction, by using zinc copper couple in presence of HCl. Zinc copper couple also we can use. Any of the suitable reducing agent. Any of the suitable reducing agent can be used to convert it into ethane. To convert it into what, children? Ethane. So overall we can say that alkyl halide are converted into hydrocarbon by reduction. By what? Reduction. So by this reduction, what you are observing that how many number of carbon atoms are there on the reactant side? Same number of carbon atom I am writing on the product side. Why I am stressing this sentence? You will come to know in the second method, B method. Now, if we'll see the second method, as we said that alkyl halide can be converted into alkane in 2 ways we said. Either by reduction, okay? Either by reduction or by using this one. Because when we are taking with respect to this reaction, the B, where is the B? B is here, correct? This is B, children. This is B. What I said, one we have written with respect to alkyl halide on direct reduction. The second method is what, children? That is alkyl halide are converted into R and R. Means one R is converted into double. One R is converted into double, and that reaction can be done by heating with sodium in dry ether. Dry ether. It is called as Wurtz reaction or Wurtz reaction. W-U-R-T-Z. Wurtz reaction. What is Wurtz reaction? When alkyl halide, here I'll write. Okay, here I'll write. What is Wurtz reactions here? Separate question for the 2 marks. Separate question for the 2 marks they'll ask. Write a note on Wurtz reaction. W-U-R-T-Z. Wurtz reaction. Very important reaction is there. I'll repeat the sentence. When alkyl halide, what is the Wurtz reaction? When alkyl halide are treated with metallic sodium. Shall I write the sentence? Alkyl halide. Alkyl halide treated with metallic sodium. Sodium metal. Metallic sodium in presence of dry ether. In presence of dry ether. In presence of dry ether to get higher alkane. To get higher alkane. Let me repeat the sentence. Higher alkane. Higher alkane represent that if a alkyl halide contain 1 carbon atom, we'll get the product with 2 carbon atom. Alkyl halide will, if we are using with 1 carbon atom, product will get alkane with 2 carbon atom. Means it will become double. If I'm going to take over here Rx with the sodium in dry ether. In dry ether, it will produce R and R. If this R contain 1 carbon atom, product will contain 2 carbon atom. If this contain 2, product will be 4. Okay. So here R and R plus NaX. While balancing this, I'll make 2. This will make as a 2. This will take it as a 2NaX, this will take it as a 2. Higher alkane, this is alkyl halide, converted to higher alkane, It is a saturated hydrocarbon only, but it is going to convert it into higher alkane. Now the question arises that if we'll take the example, okay, if we'll take CH3Br treated with sodium metal in dry ether. Whenever alkyl halide are treated with sodium metal, it will be a Wurtz reaction that you need to remember. So alkyl halide is what, children? Bromomethane. Bromomethane contain one carbon atom. So product will contain two carbon atom. Plus 2 NaBr are converted into ethane. I'll take another example. If it contain two carbon atom, alkyl halide with 2 moles of sodium in dry ether, same condition has to be maintained, dry ether condition. It will produce what? Butane. C2H5 plus 2 NaCl. This is butane. Let me repeat the sentence here. If you are taking methyl bromide, you are preparing ethane. If you are taking ethyl chloride, we are getting butane. It means that alkyl halide are two alkyl halide are there with sodium metal atom. They are producing higher alkane. If one carbon atom in alkyl halide, on the product side we are getting 2 carbon atom. 2 carbon atom on the reactant side, we are getting what? 4 carbon atom. It means that in this method, if 2 alkyl halide are different, till now I have taken same. Instead of taking 2 same, if I'll take different, how does it is happen? You see, one mole of I'll take methyl iodide, other mole I'll take it as ethyl iodide. One is a methyl iodide or iodomethane, methyl iodide, and the second is ethyl iodide. Methyl iodide and ethyl iodide, when treated with the sodium metal, again same situation. Condition will be same. We are taking sodium metal 2 moles and we are maintaining the medium as dry ether. Separately, we have taken methyl bromide, product is ethane. Separately, we have taken ethyl bromide, we got the product as butane. Now, 2 different are there. So, we'll get a 3 probable hydrocarbon. What are those? We'll see here. 3 hydrocarbons will get. One methane will react with methyl iodide to form methane with methyl. We'll get a ethane. Ethyl with ethyl will get a butane. Ethyl with methyl will produce a propane. Will get a propane. That means that when we are treating ethane, this is a butane and this is a propane. In NCERT, they have given a question over there at the end of the Wurtz reaction. What happens if 2 alkyl halide are different, are undergoing Wurtz reaction? That time you can write one sentence that if 2 alkyl halide are different, we are going to get the mixture of 3 hydrocarbon. R with R, R dash with R dash, R with R dash. Okay, like this we are going to get a 3 probable product. That's why limitations will write here. This reaction should be done only with respect to similar kind of alkyl halide. Alkyl halide must be similar. If alkyl halide is similar, then only the reaction is possible. Then only the reaction is possible. Otherwise, no. So it means that alkyl halide must be similar. One important limitation, that alkyl halide must be similar. Similar. Or sometimes we can say it is used to prepare only symmetrical alkene. Only symmetrical alkene. Only symmetrical alkane can be prepared by this method. And the one more point we can write, that by this method, by this is important point we'll write. We'll make a star mark instead of writing the point. Here Rx must be similar. Only symmetrical alkane can be prepared. By this method, we can't prepare methane. We can't prepare methane. That's why whenever we are dealing with such this one, always you can see that. Always you can see that whenever we are taking, okay, this is also a star mark. All this will be like the important note I have made here. So here we can say that whenever the Wurtz reaction are going to take place, what I said in the Wurtz reaction, alkyl halide are treated with sodium metal in presence of dry ether will produce higher alkene. By higher alkene. Now, one more point may arise to you, that why we are taking the sodium, this one metal in dry ether, because sodium metal, when we are treating in the aqueous medium, it will give exothermic reaction. That's why always you might have read in the lower classes also, maybe sodium metal is preserved under kerosene. Because of that reason, we can write over here that medium should be dry ether. Only in presence of dry ether, all these reactions are possible. I'll turn the slide over here. Have remembered, children? Here I have written 2 points. From alkyl halide, in 2 ways we can prepare alkene. One, as I said, that when alkyl halide undergoes simple reduction, by using any of the suitable reducing agent, we can prepare alkane, as I said, in A. Either you are using zinc copper couple or you are using zinc and dilute HCl, we can prepare hydrocarbon. But as we said in this, that is in the second method, it is called as Wurtz reaction. In the Wurtz reaction, what we said, alkyl halide must be treated with what, children? It must be treated with sodium metal in presence of dry ether. In presence of dry ether. In presence of dry ether. Here we have taken 3 different examples. One example, I have taken methyl bromide, product is ethane. Ethyl chloride, we got the product as butane. 2 similar alkyl halide were there, the product is alone. Product is only one. Another way, that if I am going to take 2 different alkyl halide, one is a methyl iodide, another one is ethyl iodide. That time sodium metal, because here we are going to get with respect to water, excess of sodium metal has to be added. Such a way that we are going to get the mixture of ethane, butane, and as well as propane. All the mixture are going to be prepared over here. We'll get a mixture of ethane, then butane, and as well as propane. That's why here we have written some limitation. What we have written, the limitation, that alkyl halide must be similar. Only symmetrical alkane can be prepared, and as well as methane cannot be prepared. Methane cannot be prepared. And Wurtz reaction is also called as ascending of series. Wurtz reaction is an example of ascending, ASCENDING, ascending of series. Ascending of series means what? Number of carbon atoms increases. number of carbon atoms are going to be increased as children. That's why it is called as ascending of series. Ascending of series where number of carbon atoms are going to be increased. In alkyl halide, one more point you need to remember, that we are not going to use anywhere alkyl fluoride, because alkyl fluoride is not possible. Correct? Alkyl fluoride is not possible to be prepared. So one another way we can remember, alkyl halide can be converted into hydrocarbon. How we can write the flow chart over here? We can write here alkyl halide can be converted into hydrocarbon by reduction by using zinc and dilute HCl. Alkyl halide converted into hydrocarbon by using zinc copper couple in presence of HCl, in presence of concentrated HCl. Here alkyl halide, even you can pass hydrogen gas in presence of nickel, platinum or the palladium to convert it into hydrocarbon. But the most important that when this alkyl halide treated with water, sodium metal in dry ether. In dry ether, we are going to get R and R. In all the three cases, R is only 1. In all the three cases, what I mean to say that in all the three cases, they are only 1, but here R is becoming double. That's why this method is called as ascending of series. What children? Ascending of series. This is all about second method of preparation of hydroascending of carbon, that is alkane. From where first method we have done from alkene and alkyne, and the second method is from alkyl halide. From alkyl halide. So here you need to make one more note that alkyl fluoride cannot be used. Note that alkyl fluoride cannot be used. RF cannot be used. Cannot be used under very specific condition. Under very specific condition, we can use alkyl, this one. And another point you need to remember that whenever we are dealing with the children, whenever we are dealing with such molecule, you need to observe the reagent properly. If reagent somewhere goes wrong, then everything will be wrong. That's why you need to identify the reagent. That sodium metal, when we use it, is called as Wurtz reaction. That you need to remember. Whenever we are using the sodium metal atom, they are called as Wurtz reaction. Wurtz reaction. But when you'll go to the second year, you'll see that not only whatever the example are there, which like to be studied in the first year, we have given the example. Even many of the reducing agent, like the red phosphorus, iodine, many methods are there. Even we can use PI3. These are also the reducing agent. Okay, many methods are there, but for the first PUC syllabus, whatever we need, that much I have covered. The next method is from carboxylic acid. Roman number 3 is from carboxylic acids. What is carboxylic acid? RC. Everywhere R is alkyl group. R is alkyl group. Now the question arises that carboxylic acid itself contains one R and C. So it means that you are converting R and C into respective hydrocarbon. And another point that carboxylic acids are acidic in nature. Correct? They are acidic in nature. When they are treated with base, they will form salt and water by neutralization. Carboxylic acids are acidic in nature. They will form salt and the water. If I am going to treat with the sodium hydroxide, they'll get a sodium salt of carboxylic acid with water. If we are adding potassium hydroxide, we'll get it as water, potassium hydroxide, salt along with water. So like this, we can be Like this, we can be used to prepare. Okay, we can be used to prepare. So another way we can say that when we are treating with this one, like the carboxylic acid, what happens? We'll see, children. Carboxylic acid are in that we'll see first one, decarboxylation. What is first one, children? Decarboxylation. Decarboxylation is nothing but a removal of carboxylic group. Removal of COH group is called as, this is decarboxylation. Decarboxylation. When carboxylic acid treated with sodium hydroxide, it is a neutralization reaction. When carboxylic acid treated with sodium hydroxide solution, we are going to prepare what? Sodium salt of carboxylic acid, RCOONA plus H2O. Sodium salt of carboxylic acid. When this sodium salt of carboxylic acid, shall I write the name? This is carboxylic acid. Sodium salt of carboxylic acid. When sodium salt of carboxylic acid treated with soda lime, sodium salt of carboxylic acid treated with soda lime, they are going to be heated with soda lime. Soda lime, heated with soda lime. Soda lime is the mixture of sodium hydroxide and calcium oxide. It is the mixture of what, children? Sodium hydroxide and calcium oxide, which is the ratio of 3:1. We are not at all worrying about the ratio and all. We are writing direct reaction. When we are heating, how many R are there? 1 R and 1 carbon. But the product side will get 1 R with hydrogen. And here 1 R with hydrogen, and this whatever we are going to get, that is Na. Here we are going to treat it with sodium salt of carboxylic acid. 1 minute. COONA plus NaOH. They are going to produce what? NaH. So here, sorry, RH. Here what we are getting? Na2CO3. Sodium carbonate. Na2CO3. This is called as lower hydrocarbon. This is called as what? Lower hydrocarbon. So here, sodium salt of carboxylic acid, the sodium salt of carboxylic acid heated with soda lime. What is soda lime? Soda lime is the mixture of sodium hydroxide and calcium oxide. Mixture of sodium hydroxide and calcium oxide are called as decarboxylating agent. Called as decarboxylating agent. 1 minute. Decarboxylating agent. They have asked many times in exam. In 1 mark, what is soda lime? Soda lime is the mixture of sodium hydroxide and calcium oxide. And soda lime is used as decarboxylating agent. Where we are using decarboxylating agent, children? Sodium salt of carboxylic acid When treated with soda lime, heated with soda lime, what we are going to get? We are going to get it as a lower hydrocarbon. So how many number of carbon atoms are there? On the product side, we are getting 1 carbon atom less. On the product side, we are getting 1 carbon atom less. That's why those are called as decarboxylation, where carbon dioxide will be evolved as a from the carboxylic group. That's why it is called as decarboxylation, removal of carboxylic group. Let us move to the example now, children. I'll take the example. Sodium acetate prepared from acetic acid. Sodium acetate prepared from acetic acid with the sodium hydroxide. Neutralization occurs to get sodium acetate. This sodium acetate by fusing the mixture with the soda lime. Sodium acetate by fusing the mixture with the soda lime, sodium hydroxide and calcium oxide by heating. Okay, by heating the mixture of sodium acetate and as well as calcium oxide, we are going to heat it at high temperature. When we are heating at a high temperature, we are going to get here 2 carbon atoms are there. We'll get a 1 carbon atom hydrocarbon. 1 carbon atom hydrocarbon along with what we'll get over there, children? We'll get it as Na2CO3, sodium hydroxide. Here there is a liberation of methane. And here you have to maintain the temperature more than 600 Kelvin, as we have to take it as approximately we are going to take it as 670 Kelvin. By high temperature, when the soda lime, this is the soda lime mixture. Soda lime mixture. We are going to prepare what? Lower hydrocarbon. 2 carbon atom carboxylic acid are converted into 1 carbon atom. If I am going to take 3 carbon atom carboxylic acid, CH3, CH2, COONA, sodium propanoate. Sodium propanoate on heating with the soda lime. Heating with soda lime. There we are having 3 carbon atom and the product side will get a 2 carbon atom. CH3, CH3 plus Na2CO3. We'll get it as what? Ethane. We'll get it as what, children? We'll get it as ethane. So here we can use it as, and remember one thing, sodium hydroxide while using, we should be very careful that it will absorb the moisture, this one, water droplet from moisture. That's why it is called as hygroscopic in nature. Sodium hydroxide is hygroscopic in nature. Sodium hydroxide pellets, it will be available in the lab also. Just we'll keep it in the watch glass. After this one few minutes, we can see that upper layer will be like the soapy touch. It will be soapy touch. It is due to what? Absorption of moisture, absorption of water droplet from the moisture. That's why it is hygroscopic, called as hygroscopic. And calcium oxide is what? It is a dehydrating agent. Best dehydrating agent. Sodium hydroxide nature. In the note, we can write hygroscopic. Just for the additional, you can write over here. Why we are taking this mixture, you may think, why we are taking, because sodium hydroxide is only the going the reaction, not calcium oxide. Because calcium oxide will be what? Dehydrating agent. Dehydrating agent. This is the reaction where carboxylic acid are converted into lower hydrocarbon. That's why decarboxylation is an example of descending of series. Got my sentence? What I said, Wurtz reaction is ascending of series. Then here I'll write that decarboxylation is descending of series. Descending of series. Decarboxylation is an example of descending of series where number of carbon atoms decreases. Number of carbon atom decreases. That's why it is called as descending of series. Called as what, children? Descending of series. Here, from the carboxylic acid only, one more method is possible to called as Kolbe's reaction. Kolbe's reaction. You can see here, from carboxylic acid, decarboxylation we said. From carboxylic acid, two methods are there to convert it into hydrocarbon. One is called as decarboxylation. Correct? Another one is called as Kolbe's reaction. Another one is called as Kolbe's reaction. Already we have completed everything for decarboxylation. Now let us move toward, children, Kolbe's reaction. Kolbe's reaction. What is a Kolbe's reaction? Here this method of reaction is electrolytic reaction. This is electrolysis. Whenever the substance or the electrolyte which dissociate, the substance which dissociate in aqueous medium are called as electrolyte. Which dissociate into cation and anion in aqueous medium or the molten state, they are called as electrolyte. And here, then the potassium or the sodium salt of carboxylic acid, they act as a best electrolyte. When they will undergo ionization or the electrolysis, they will produce hydrocarbon. See here, RCOONA, we can take K also. Sodium or the potassium salt of carboxylic acid, they will undergo electrolysis in aqueous medium. Electrolysis. Always you need to remember that acetic acid or the carboxylic acid, acetic acid, benzoic acid, all these are what, children? They are forming weak electrolyte. When they will undergo this one, 1 minute. When they will undergo weak electrolyzation, they will form RCOO minus and OH minus, or H3O plus. H3O plus, because carboxylic acids are weak acid. Weak acid will undergo partial ionization or incomplete ionization. Let us come to the bit, Kolbe's reaction. According to the Kolbe's reaction, sodium salt of carboxylic acid, sodium salt. sodium salt of carboxylic acid on electrolysis. Electrolysis, they will produce R with R. That's why we'll take R as 2. R with R along with NaOH with the liberation of hydrogen gas and carbon dioxide gas. Is it balanced? 2 R are there. Then 2, this one, hydrogen, how many are there? 2 plus 2, 4. Okay. Here we'll take hydrogen as 2. 4 to the 8, 8 plus 2, 10. Then 2, 2 to the 4. Correct? Then here we can take the oxygen as how much, children? 2 to the 4 plus 2, 6. 2 to the 4 plus 6. This is alkene. This is alkane. So we can say that when we are dealing with electrolysis, always remember that sodium or the potassium salt of carboxylic acid on electrolysis, hydrocarbon. They will produce hydrocarbon, means 1 R. RCOONA are converted into R and R. Where does this oxide will liberate as carbon dioxide? Actually, in this reaction, how does the mechanism are going to take place? Because electrolysis means what? We are going to take the salt, this one sodium salt of carboxylic acid in aqueous medium in a container. Then what happened? In a container, by the passage of electricity. Okay, by the passage of electricity, we have 2 electrodes are dipped over there. Correct? 2 electrode, one act as a anode, one act as a cathode. Anode is a positively charged electrode and cathode is negatively charged electrode. Therefore, during electrolysis, what happened, children? During electrolysis, always the carbon dioxide will be liberated at anode and hydrogen will be liberated at cathode. That's why when we are writing the reaction, always we should write anode and cathode reaction separately. Anode and cathode reactions are most important. Here at the anode, as we know very well that sodium salt of carboxylic acid will undergo decomposition. Correct? When it undergoes decomposition, what happened? RCOONA will dissociate to form RCO minus and Na plus. Whereas water is the weak electrolyte which dissociate partially to form H plus and OH minus. Sodium salt of carboxylic acid is a strong electrolyte. Carboxylic acid is a weak electrolyte. So here sodium salt of this one, RCOO minus. In redox reaction, you'll see that always at anode there is a loss of electrons. And at cathode, gain of electron. At cathode, gain of electron. So here by the loss of electron, we are going to get, by the loss of 2 electron, here at the top only, right? By the loss of 2 electron, they will form, here they will form a complex, or we can say that a unstable molecule, very highly unstable. Highly unstable. Highly unstable. And that unstable are further converted into methyl free radical with the release of carbon dioxide. Or I'll write without example only. Afterwards, you can write yourself the example. Will liberate what, children? It will form R with a dot with the release of carbon dioxide. free radical, and the free radical and the free radical combine to form R and R, and carbon dioxide is going to liberate it anode. Carbon dioxide is going to be liberated, what children? At anode. Carbon dioxide is going to be liberated anode. In the same way, if I am going to take OH minus, that is H plus, OH minus and H plus. H plus will gain electron to form. 2 electrons are gained, they will form H2 gas. And they liberate hydrogen gas at cathode. At cathode. That's why, but in exam, they'll ask the question separately for the 2 marks, that write a note on Kolbe's reaction. How does the Kolbe's electrolysis are going to be takes place? That time we can write that sodium or the potassium salt of carboxylic acid on electrolysis in aqueous medium. On electrolysis in aqueous medium, they will form saturated hydrocarbon. Example, let us write one example. CH3COONA, sodium acetate. Sodium acetate. Okay, sodium acetate on electrolysis in aqueous medium. Sodium acetate on electrolysis in aqueous medium will produce ethane. Correct? With the formation of sodium hydroxide, with the release of carbon dioxide at anode and hydrogen at cathode. At cathode. Is it visible? Na? Hydrogen at cathode. Yes, it is visible. We'll balance the equation. 2 moles. This will also be 2 mole. CH3. This will be 2. This will be 2. This will also be 2. Na? 2 2s are 4. We are going to take a 2 moles of sodium acetate in electrolysis in presence of aqueous medium will produce ethane. What will produce here? Ethane along with sodium hydroxide with the release of carbon dioxide. Hydrogen is balanced or not once you check, children. 3 plus 3, 6. Here how many are there? 6 plus 2, 8. 8 plus 2, 10. Here 3 2s are 6, 2 2s are 4, 10. Yes, it is correct. How many oxygen are there? 2 2s are 4 plus 2, 6. 2 2s are 4 plus 2, 6. Hydrogen is automatic balance. Okay. So here we are going to take with respect to the sodium acetate. What happens with this one? That is Kolbe's electrolysis. Product will be ethane. Product will be what, children? Ethane. One minute. Product will be ethane. So here we are going to take what, children? If we are going to take sodium acetate, we'll write the reaction at anode and as well as we'll write the reaction at cathode. At cathode. CH3COO Na will dissociate to form CH3COO minus and Na plus. CH3COO minus will loses 2 electron to produce what? CH3COO dot will get here. Actually, we'll get water like unstable, this one, the molecule, unstable molecular free radical, then which are further converted into water, which are further down, I'll write ethane with the release of carbon dioxide. The release of how many number of electron will be lost? Those many number of electron will be gained at cathode. That's why H2O, H2O on ionization, electrolysis will produce H plus and OH minus. H plus and what, children? OH minus. And that OH minus with respect to the H plus will gain one electron. H plus 2 are there. We'll take 2 electron over here. They will produce hydrogen. Hydrogen gas is liberated at cathode and carbon dioxide gas is liberated at anode. These two are the very important point are there, children. These are the very two important point where we can understand that how come it is possible to prepare. Another way, from carboxylic acid. What I said, carboxylic acid are converted into hydrocarbon in 2 ways. I have written here. In 2 ways, it is possible to be prepared. What I said, first one, decarboxylation. And the second is what? From Kolbe's reaction. From Kolbe's reaction. Here I have written, you see. I have get back to the same, this one, the slide. You can see over here, as I have written, but by decarboxylation and another one by Kolbe's reaction. By decarboxylation, descending series. But in the Kolbe's reaction, how many number of carbon atom? Because we are going to, it also comes under descending. Because the molecule are containing 2 carbon atom, but R is only going to become double. And in this Kolbe's reaction also, we cannot prepare methane. We cannot prepare methane, children. These are the 2 successful methods are there where it can be applicable to prepare alkane. It will be applicable to prepare what, children? Alkane. And the one more method, actually they have not given in this one, in the NCERT. But in the exercise, they have given one method. How come it is possible to prepare hydrocarbon from respect to metal carbide? Write the next method. 4th method. Only 3 methods they have mentioned in NCERT, but we'll see the 4th method also. Write the 4th method. 4th method is from metal carbide. Write the 4th method. From metal carbide. Write the 4th one. 4th method. From metal carbide. Usually metal carbide are prepared from acidic hydrocarbon. Alkene and alkyne, it is what? Alkyne are acidic in nature. They are prepared from 2 metallic carbide. Two metallic carbide are there. One by hydrolysis of aluminium carbide. Aluminium carbide. Al4C3 is called as aluminium carbide on hydrolysis. Aluminium carbide on hydrolysis, it will produce methane. AlOH taken thrice. Aluminium, how much we have to take? 4 Al and 3 carbon. 4 and 3. Okay. So how many are there? Al4C3. So here hydrogen, how many are there? 3 4s are 12. 4 3s are 12. 12 plus 12 will be 24. This will become 12. 12 oxygen. Yes, 4 3s are 12 oxygen. Methane can be prepared. Methane can be prepared by this. And the one more metallic carbide is beryllium carbide. Listen here. Metallic carbide, actually they have not mentioned in this one the point, but many times they have asked in this one the question paper, and as well as in the exercise they have asked the question. One more method is from hydrolysis of beryllium carbide by hydrolysis of beryllium carbide. By hydrolysis of beryllium carbide, that is Be2C. Beryllium carbide hydrolysis will produce methane. Methane along with beryllium hydroxide. Beryllium hydroxide. 2 to the 4 we can say. 4 plus 4 will be 8. This I'll take it as 4. Is it correct? 2 to the 4. Yes. Beryllium carbide is going to be prepared what? Lower hydrocarbons are gases in nature. Methane. These are the 3 successful methods are there by which we can, these are the 4 methods are there. One method from alkene and alkyne. Together we have discussed alkene and alkyne. The next method is related with alkyl halide. In alkyl halide, we said general reduction and as well as Wurtz reaction. Then same way in this one, the carboxylic acid, decarboxylation, Kolbe's electrolysis. Metal hydrolysis, they may be a metal carbide hydrolysis, they may be aluminum carbide or they may be beryllium carbide. They may be aluminum carbide or they may be beryllium carbide, which on hydrolysis gives respect to hydrocarbons. These are the 4 methods are there for the preparation. Doesn't mean that only these 3-4 methods are there. Many methods are there, but sometimes they will involve more than one step. More than one step to go for the answer. That's why when we are preparing for this one, children, you need to remember that method of preparation will involve more than many methods are there. Many methods are there by which we can prepare this one, the hydrocarbon. The next bit of the topic is water, physical and chemical properties. Physical properties of alkenes. Physical properties of alkenes. As we know very well that alkanes are non-polar, yes, and physical state, if we'll see, lower hydrocarbons are gases, lower alkanes are gases, but higher are liquids and solids. But higher are liquids and solids. Liquids and solids. And another point, that boiling point. Another important point is boiling point. Boiling point depends upon surface area. Surface area. It means that larger is the surface area, higher will be boiling point. Higher will be boiling point. If I am going to write all the carbon atoms in a normal chain will be having higher boiling point as compared to iso, as compared to neo. Because branching increases, normal chain are converted into iso, iso can be converted into neo. That means that as the surface area increases, boiling point are also going to be increases. For example, if I am going to take normal pentane, boiling point is around 309 Kelvin. When I am taking the normal pentane, it will become it as a 309 Kelvin. If we are going to take isopentane, CH3, CH, CH3, CH2, CH3, it will be 301 Kelvin. It will be what? 301 Kelvin. If we are taking water, neopentane, it will be approximately 283 Kelvin. 283 Kelvin. So larger will be the surface area, lower will be the boiling point. Surface area depends upon boiling point, and all the hydrocarbons are water. They are non-polar in nature. It means that they are insoluble in water, but they are soluble in organic solvent. Organic solvent. These are just the physical properties, but amongst the physical property, this part is very important, children. Amongst the normal isoneo, completely branch, any of the molecule will be given to you. Need not to remember the parameter, but remember that all the carbon atom are arranged in an open chain. They are having high boiling point as compared to one branch, two branch, completely branch. It depends upon surface area. Surface area, because surface area will decide vapor pressure. That's why in the yesterday's topic also during purification, we have discussed related with boiling point. Let us move to the chemical properties. Chemical properties of alkenes. Alkanes are paraffins, already we said. So reactivity will be low, low reactive, low chemical reactions are possible. Less number of chemical reactions are possible. But one of the special kind of the reaction which are possible in alkane is substitution reaction. That too free radical substitution. Substitution reactions. That too free radical substitution. Free radical substitution reaction. Here, hydrocarbon RH, when they undergoes halogenation, X2, X is halogen, in presence of diffuse sunlight, it is a photochemical reaction, or at high temperature. At high temperature, one of the hydrogen atom here replaced by X, Rx plus Hx. Plus Hx. This is what? 1 minute. Rx plus Hx. This is alkyl halide. Alkyl halide. Here, this X2 may be fluorine, chlorine, bromine, and iodine. Remember here, fluorine gives highly exothermic reaction, violent reaction. Violent reaction means exothermic reaction. It liberates enormous amount of heat energy. That's why it is not preferred. Okay. Iodination is reversible. It should be done in presence of oxidizing agent, in presence of HiO3. It is a reversible. Bromination is very slow. Very slow. That's why most preferable is chlorination. Most preferable is what? Chlorination. When hydrocarbon undergoes halogenation in presence of diffuse sunlight, or in presence of what? Photochemical reaction. It is in presence of diffuse sunlight or a photochemical reaction or at a high temperature. One of the H is replaced by X. Means alkane are converted into alkyl. Into what, children? Alkyl halide, where H is replaced by X. H is replaced by X. Now, amongst all, the most preferable is what I said, chlorination. Chlorination. Here in this chlorination, let us see one by one. First one, chlorination. Chlorination of methane, we'll write methane only directly, because we'll take with the example. Without example, you cannot understand. Methane, when undergo reaction, chlorination, as I said, it is a free radical substitution, and free radical is a chain reaction. Chain reaction means what? Till you get a free radical, reaction is going to be continued. All the free radicals should combine to form a neutral molecule, then only reaction is going to be stopped. Diffuse sunlight, we are going to get it as methyl chloride plus HCl. Chloromethane. You can write IUPAC name. This chloromethane, on further chlorination, same condition, replace one more hydrogen atom by chlorine plus HCl. This is called as dichloromethane. This is called as what? Dichloromethane. Then dichloromethane, further on chlorination, in presence of diffuse sunlight, to convert it into trichloromethane. Trichloromethane. Trichloromethane on further substitution means we are replacing one by one hydrogen atom of methane by Cl. With chlorination, again with the diffuse sunlight, same condition, UV light or Hnu or high temperature, converted into CCl4 plus HCl, carbon tetrachloride. Carbon tetrachloride. This separate question they'll ask in exam for 2 marks. How they'll ask the question? Write a note on chlorination of methane. One line sentence we can write that. Methane on chlorination in presence of diffuse sunlight, successive substitution takes place to get it as carbon tetrachloride. Methane, one hydrogen atom is replaced to get a methyl chloride to dichloromethane, dichloromethane to trichloromethane, trichloromethane to carbon tetrachloride. These are the method are there by which we can substitute one by one hydrogen atom of alkane by halide group. One by one hydrogen atom of alkane by what, children? Halide group. And here, as I said that this one, the bromination is very slow process. That's why we are not going to be preferred. Whereas iodination is a reversible. If we are going to take the bromination also, bromination is very slow step. That's why not at all preferred. What happened in the iodination, that when alkyl halide, okay, when alkyl iodide are formed, they are further converted into what? Iodine molecule. They are further converted into iodine molecule. That's why they are not preferred. The most preferable is what, children? Chlorination. More preferable is chlorination. In the next class, we'll see this mechanism. This mechanism. Be present to all the classes, children. Watch this one, the videos. Any doubt, anything are there, just you can post the question. And after posting the question, wait for at least for few time, because sometimes we too will be busy with our this one own schedule. You cannot, this one, in 1 minute, we cannot answer. We'll be having classes and all in between. That's why post your question. Whenever I'm getting the time in between, I'll post your answer. Okay. Thank you one and all. We'll wind up here.